Okay, so new year, new lesson, new booklet. We're gonna start with the trigonometry. This one here is an introduction to triangles. So we're gonna learn about, our goal is to learn about the 180 rule, 180 rule. And then you're probably thinking, what is that? We'll find that out later, pretty soon. I'm gonna zoom this in a bit. And then we're also going to recognize and distinguish between the various types of the triangles, different kinds of triangles. Let's see here. It says here, what is trigonometry? What is trigonometry? Trigonometry is an area of math that studies the relationship involving the length and angles of triangle. Of triangles. A triangle is a three-sided shape with three sides and three angles. So we already know this from way back in elementary, right? A triangle has three sides. Okay, we always say a triangle has three sides, but also when we were younger, we didn't really say three sides and three angles, right? We just had three sides. So now let's introduce the 180 rule. What is the 180 rule? The angles of a triangle are measured in degrees. Okay, we know that. Measured in degrees. And the three angles of any triangle always add up to 180. So that's the reason why it's called 180 degree rule, is because when we have the angles in a triangle, it always adds up to 180. Always adds up to 180. Okay? So I'm going to show you a little bit of an activity. I'll show you this for a second. Here. So I'm just gonna do a quick sketch of a triangle. We know what a triangle looks like. So here's a triangle. So these lines here are called the sides, but where are the angles? Where are the angles in a triangle? Where is it in this picture? So the angle are if you are from this side and then you swing to this side, not an opposite side, the other side, this is the angle. Okay, so that's an angle. And then over here, let's say you're in this side and then you swing this way. So that's this angle over here. Okay? Now if you're in this side and you swing to the next side, that's another angle. Okay? So you have, this is one angle, this is another angle, and then this is another angle. And what they're saying here is that all of these three angles, when we add them up, it should add up to 180 degrees. 180 degrees. And here's the other thing too. Well, you're probably thinking, well, that's that triangle. What about What if we draw the triangle differently? What if we draw the triangle slightly different? What if we do it this way? Okay. What if the triangle looks like that? Is it still 180? Okay, so this is your angle. That's your angle right there. Here's your angle right here. And another one there. Okay. So when we add these up, it would still be 180. Okay, it would still be 180. And then you're thinking, okay, well, what if I create a really, really small triangle? What if my triangle looks like this? What if my triangle is like that? Okay. Does the rule of 180 still hold? It's like, okay, this angle here plus this angle here plus this angle here. Yes, it would still be 180 degrees. 180 degrees. Okay? So the rule of 180 is always true, and it doesn't matter how small or how big the triangle is. It's talking about the angles, the rotation from one side to the other. Okay, so is everybody okay with that one? Yeah. Okay. So in this activity, we're going to do this activity right away. Determine the measure of the unknown angle. Okay. So what they're saying is, okay, we know the 180 rule. We know that if we add up all of the angles in a triangle, it always adds up to 180. So let's say I have this number. This angle is 73. And then this angle is 64 degrees. Is there a way to figure out this missing or unknown angle? Is there a way for us to figure it out? How can we figure that out?
180 minus 73 plus 64, take away 180.
Okay. So now, like, some people are saying something. Yeah. Okay. I hear two strategies going on. Okay. And okay. I'll show you those two. Okay. So this is strategy one. Number one. Okay, strategy number one. And this is what Soon had said. She said 180, take away 73, take away 64. Okay. Oh, what does that equal to? 180 minus 73 minus 64. I got 43 degrees. 43 degrees. Okay. Good. Very nice. Very nice. Good. Now, another student. Okay. Sean has a different strategy. You want to explain that again, Sean? What were you saying earlier?
73 plus 64, take away 180.
Yeah. So what he's saying is that, I'm going to add 73 and 64. Okay, I'm going to add 73 and 64. Okay, what does that equal to? Is 137. Okay, so far I have 137, and then you take away 180, so take it away from 180, and that's also 43 degrees. Yeah. Okay. Is that good? That's pretty awesome. We got two different ways of doing things. So we got 180 minus 73 minus 64 to get the whatever is the remaining angle for that theta. And strategy number 2, I like the fact that we have two different ways of thinking. 73 plus 64, that only gives us 137 degrees, right? But then we have to, well, how much more do I need to make it 180? So 180 minus 137, 43 degrees. Very good, very good. So I'll write that down, both of them. Okay. I'm gonna write both of them down, but like for you, you can choose which one you like the best. Okay? I'll get you to pick which strategy you like the best. So strategy 1. I go 180 minus 73 minus 64, which is 43 degrees. And then strategy number 2, added the 73 and 64. That only gives us 137 degrees. And then from there, we're gonna go 180 minus 137, which is 43 degrees. Very good. How do we deal with number 2? Why don't you go ahead and try number 2, and I'll do the same thing too. You okay? Okay, we're only gonna do number 2 for now, okay? So, theta, and yeah, theta is just a symbol, I didn't really specify what theta is. Theta is a symbol that was used, okay, to figure out the angle. Okay, so it's nothing special, it's just a Greek letter. Theta. And I don't know, like, I mean, they could use theta, they could use angle A, could be a regular letter. So yeah, that's just a symbol, it's not a big deal. So strategy, I'm gonna do 2 strategy. Strategy number 1, I could go 180 minus 19 minus 75. Okay. 180 minus 19 minus 75, and I got 86 degrees. So this angle here is 86 degrees. Okay, What about strategy number 2? Okay, strategy number 2. If you like this one, you could go, okay, I know I have 19 degrees and I have 75. So 19 plus 75, I got so far 94 degrees. Okay, how much more do I need to make it all 180? So I can go 180 minus 94, which is 86 degrees. So this theta here is 86 degrees. So you can put it right into the picture. Now number 3. You're probably thinking, how can we solve this part here when there's just that part? It's just that part.
Same thing, using strategy 1.
Yeah, you can do it strategy. Anybody here knows what this means? 90 degrees. Yeah, okay. So when you see a symbol like this, okay, at the corner of a triangle, and it doesn't specify what number it is, this is actually telling you that this is a 90 degrees. So that means that the horizontal and vertical makes a 90-degree angle. They're perpendicular to each other. Okay? Is that good so far? So if this is 90 degrees, I know it didn't say 90, but that's what that symbol means. Can we figure this out? Okay, so how can we figure that out? Okay, I'll do strategy 1. 180 minus 90 minus 45. That's 45 degrees. And strategy number 2. I know that this is 90 plus 45. That's 135. So far I only have 135 degrees in my angle. So I have to go 180 minus 135, which is 45 degrees. So this angle up here, where the theta is, that's 45 degrees. Okay, so far so good? Any idea of how to do number 4?
180 minus 40. 140 divided 2. 7.
Okay, yeah? You okay with that? Did everybody hear? Would you repeat it again? That's okay.
Strategy 1 is total 180
Okay,
minus 40 equal 140.
okay,
And the two angle in the same divide 2.
okay.
140 divide 2 down 77.
70 and 70. Okay, okay, very good. Okay, very
More
good. Yeah, okay, that's good. That's in this case, that's the only strategy for this one. Yeah, okay, good. So let's write it down, make it official. So this is what she's saying. I know 180, if I take away 40, I have 140 degrees left. 140 degrees left for these two. I got 2 of them, so 140 divided by 2 thetas, divided by 2, because you have the 2 theta there, it's going to give us 70 degrees. Does that make sense to us? Yeah? Yeah, because I have to do, that 140 has to be divided evenly between these two. Okay? So that makes this 70 degrees. And then the other one is also 70 degrees. Good? Okay. Let's figure out 5 and 6. So I'll let you figure that out. I'll write down that final answer. Okay, I'll just give you the answer for that one and that one. Is everybody okay with number 5 and number 6? Did I give you enough time to figure it out? Okay, yeah, just to let you know, just stick with one strategy. You don't have to do both. Okay. So it's all good? The second part of that, page 2, talks about the types of triangle. Types of triangle. Okay? So here's type number 1. So triangles can be classified according to the characteristics of the length of the sides and the size of the angles. So it says here, this triangle, it's called equilateral triangle. What do you think these lines mean? The same side, right? We saw this last time when we talked about the geometry, right? When you have their sign that tells you that these are all the same sides, same length. So equilateral, okay. I'm gonna break down the word equilateral, okay? Because once we break down the word, then you're probably thinking, oh, now that makes sense. Now, look at this word here, equal. What does that kind of sound like? Equal. So it kind of talks about equal, equilateral, right? Equal. And the word lateral means pertaining to the sides. So if you are taking biology, sometimes they tell you, like, the word lateral means pertaining to the side, right? So equilateral means equal sides triangle. Okay? So all side lengths are equal in length, and all angles are the same size. Therefore, each angle measures 60 degrees. They're saying all sides are the same, and these are all 60, 60, 60. So if you go 60 plus 60 plus 60, that gives us 180 degrees. Okay? So that's a great thing about equilateral. All sides are equal, and then all angles are equal. Now let's take a look at the next one. Isosceles triangle. I haven't found a way to explain the breakdown of the words just like the equilateral, but isosceles triangle has two sides that are the same length, and the angles, two angles are the same measure as well. So these two sides are equal, and then these two base angles are equal. Okay. Now I don't have a specific values for those because we don't know how big they are. Oh, hello. Okay. Now, that's an isosceles triangle. Let's take a look at the right triangle. Okay, what is that right triangle? We're going to spend a lot of time talking about the right triangle. Yeah, this is yours. We're on page 2. Page 2. So we're going to spend a lot of time doing a right triangle. So it says a right triangle has one 90-degree angle and two acute angles. Okay, so where's the 90-degree angle? We talked about 90-degree angle. It's where this square is. That's 90-degree angle. And then two acute angles. So these angles over here are all acute. Okay, acute, okay, means smaller. Smaller than 90 degrees. Okay? Yes? So this is what I tell my students sometimes, like, oh, when something is small, it's like, oh, they're cute. Cute. Joke. That was a joke. That's my first joke of the year. Right? Small, because so they're cute. Right triangle. And last but not the least, a scalene triangle. A scalene. This one here, all sides are different lengths. And I want to actually add a little bit more to that one. A scalene triangle has three unequal sides. Okay, none of them are equal, and then all angles are unequal as well. So none of the angles are the same. Thank you. page 2. Page 2. And that's the only thing. Okay? And that's basically it. That's a nice way to start the year, right? And the lesson. So very friendly lesson today. Talking about the Rule 180. And then the types of the triangle. Okay? So that kind of leads us to this part here. Let's focus that for a second. Yeah. So assignment number 1 is just question 1 is identifying, is it equilateral? Is it isosceles? Is it a right triangle?